Right, so this is going to be wrap up by myself. We had our Zoom meeting from 4 to 5, and 4 to about 4:30, and then I realized about halfway through that I was not recording it. So I'll just start over. We'll go quickly through it. There's not a whole lot of new stuff today, but let me go ahead and share the screen. Yes. Okay. And share screen. There we go. Sorry, I was talking to me. All right. So Monday, this is the 14th class. Like I say, Pkt2 is going to be a bit of a marathon. It may end up virtual, who knows? But right now, Monday the 9th, and there's nothing new on this calendar. I'll always put the calendar up on Monday just so we can kind of see what's happening this week. And so last night I turned in our grades. I didn't turn in the grades, but I posted the grades for the 300-point test. And that did definitely adjust the grades. Now, I may have to bump the cushion up to 100 out of 100. That'll help a little bit more. Let me see what the damage is. I told him I'd take the cushion away, but I definitely don't want to do that until black and blue are in, which is going to be Thursday. So I may take that cushion away over Thanksgiving, or before Thanksgiving. But the cushion, all these points that keep piling on, the cushion becomes less and less of a deal. So I posted a PDF of Take on THT2A. I have one in class. If you're going to be in class, you can just come by and pick one up. If you're virtual and you're watching this and you don't have a printer, you can come by my porch, 812 Carriage Lane, and in the handouts box, you'll see it. Also, I was showing them that for the virtual kids, they have a folder now, a file folder on the porch, which has each individual student. So, FERPA. So when I hand back the tests, like the virtual kids come to the porch and get their test, you won't see anybody else's. I mean, you're not supposed to be snooping, but it's there in your little slot. Okay, it has your name on it, except Miranda's fell off. But anyway, she'll figure out where hers is. And also in there, you have your packet and you have notebooks, things like that that I'm handing back to you, virtual kids. But if you're in class, just wait and pick it when you get to school. So today we handed out, sorry, let me pause. I'll take this. Hold on. Pause it. All right, that was Jamie calling. She's getting reversals. So tomorrow by 4 o'clock, I'll have a key posted on a video key posted on the test, like me going through each problem. And I'll try and be quick about it. I'm not just going to work it from scratch, but I'll have the key and then I'll explain the problem. All right. So it should be pretty quick. Blue, this little symbol here, when you have these boundaries as the blue and black, those are black and blue days, and that means that you get points back on your test. So you want to get your test back. You should have it back if you're in school. If not, you'll get it back tomorrow. But if you're virtual, you got to come to the porch to get your test. So you'll correct some problems, and some problems are blue, some problems are black. Let's see. We went over it in class, but let me tell you this: 1A, 1B, 1C, they're all blue. Now 2 through 6, no. You can't do black and blue on multiple choice questions. 7, A and B are blue. 8, A and B are blue. 9 is blue. That means you get half credit back when you work it. Half the credit that you lost. Half the point that you lost. 10 is blue. 10A, 10B are blue. 11 is blue. 12 is black. 12 is black, and 13 is black. Enough people missed, I felt on those that it was probably too much, maybe, or just weren't ready for it, I guess. and 14 is blue. And the reason, the 14 is the essay, but the reason why, a lot of people didn't get it perfectly right, but I gave you half credit on that one if you talked about like say you're wrong, but you're trying to use logic. You're saying, well, the Earth's rotating at the same speed as that. If you gave that a lot of thought, I think it doesn't take the Earth a month to go around once, right? So we're rotating a lot faster than the moon is moving about us. So that doesn't work, but it was a good shot. And so it was kind of a surprise question, that essay question on the moon. So yeah, I gave you half credit for that. And then, but a lot of people got it perfectly right. So I guess we ought to say a word about that. And that comes here, there's black and blue. And we talked about that right here today in class. This is the reason why the moon appears, even though it's going at 2,300 miles an hour, it appears to be moving really slowly, because we only perceive speed by the rate at which our eyes rotate or our head rotates. And from there, we do a quick guess on the radius. Our mind does this. And then from there, you calculate speed, or you calculate your perception of speed. So speed itself, velocity, is almost it's really happening, but it's almost a construct of the eyes rotating and then multiplying by the radius, how far away it is. Like a little kid in a scooter goes zooming by you at like 6-7 miles an hour, or say 6 or 7 meters per second. You're thinking that kid's pretty fast. But then a moon is going at 2,300 miles an hour, much, much, much faster, and it appears that it's barely moving. And the reason is the radius. If I'm following the moon with my finger, I go really slowly. But if I'm following that kid riding by in a scooter, that kid my finger moves fast. So velocity, you have to have, for velocity, you have to have R and omega. But here's something else that happened, not just on that problem, but on a lot of problems. And this happened, if it happened once or twice, I'd say, okay, but it happened like 15 times out of 80. That's what we got talking about. These are notes from our discussion. But we started talking, look, there's a lot of things in physics that are A is equal to B times C. Okay, a lot of formulas like that in physics. In electromagnetics and mechanics, all throughout. Ohm's law, all these things are A is equal to B times C. So some people, like I saw this way too many times in the test, they would say that V equals R omega, and then they would solve for omega, and they'd say, okay, therefore omega equals V times R. No. Okay, that is not true. That is not how you isolate a variable. Okay, if you want to get rid of the R, you divide both sides by R. R's go away, and you're left with a V over R. Okay, I've never seen this many people have trouble with that, but something ain't right. And in fact, we're going to have a summit with the math department, sciences, because we get you guys after you've had math. And some people are having math back in 7th grade. I don't think it's stuck. I don't think it's stuck very good. And I'm not blaming you guys. It's just, we could do a better job of education. Anyway, so if you need a crutch on that, which you might, for now, you'll pick it up. But for now, you might want to crutch a little bit. So this is called the magic triangle, and it's a nice little mnemonic to have. Okay, like for instance, for velocity, if I take if I want to find omega, that is, I cover that up, that is V over R. If I want to find radius, I cover that up, that's V over omega. If I want to time velocity, I cover that up, that's R times omega. So that's called the magic triangle. And yeah, it works. It works for a lot of things, actually. So that's that problem on the test, that last essay question. You're supposed to put all that kind of stuff in words. For the take-home test, there is on the Facebook and on Canvas, there's all these instructions on how to do these take-home tests and if it's late and what do you do if this, if that. Okay, so that's on there. Now remember on the Facebook group, this is there now. Each problem on the take-home test is posted individually, and then there are comments. So you want to comment here about it if you have a question or if you want to answer a question. So there's question number 2. That's a derivation. That's right out of your notes or on screenshots. And then 3, this is, this, by the way, this needs to be highlighted. This needs to be thickened up. That's supposed to be flat there. I didn't do a very good job of that. Okay, so start working on that. It's not due until the 17th. It's not due until a week from tomorrow. By midnight, you're going to submit that take-home test. And for take-home test, there's number 1. This is like me following that plane, flying overhead at a campsite. Number 2 is the derivation like we showed. 3 is the slope graph. 4 is finding these, coloring in these areas, positive and negative, and then figuring out the areas of each, and then putting that in this table, and then plotting over here, how the area is accumulating. It's really not area. I mean, it is area, but it's position. We're accumulating position. This one's on the finger dance, and I'm going to let you ask your questions there, but you start right here. You're going to have some kind, this is probably a nip, you're going to have some kind of pattern, okay? Oops, make it nicer than that. You have some kind of pattern. You see, if you go color this in, you see that's going to go that way, and then this is going to go like that. So you first you color in each one of these, the positive and the negative rectangles, and then you figure out the areas. You can do a T-chart, but this is telling you where on the meter stick were you. So it's your location. So I'll just let you think about that. You're gonna have a series of arrows up here. Arrows, all right? And then you gotta fill that in, all right? So enough said. 6, there's your gold standard for this test. I've tried to make it a little nicer for you on the little more user-friendly. And 7 is doing the trio. So remember here, you're gonna do all those each second. You're gonna come across like we've been doing in class. You're gonna come up, you're gonna draw a triangle. And you're gonna go across here. You're gonna go up, you're gonna draw a triangle. You're gonna color in those triangles. Yeah, and you figure out what the slopes, you're figuring out these 1 second slopes. We call them 1 second secants. 1 second secant slopes. And then you're going to put that data, over here. And then you're going to plot that step function, step. And then you're going to find that you do a best fit line. And you're going to, sorry, that's terrible. We'll do a best fit line through those. And then you'll come down. And you got an essay here. You got an essay. So essay to your right about what the heck you're doing. So that's the take-home test that we have this week. We did a joke Monday. Lucille Ball. Oh, it's good. It's from the old I Love Lucy, from the Vita, Veggie, anyway, that drink she had. It's a famous bit. It's a little history to the joke Monday today. Now, for the physics review, and I talked about this on the wrap-up video quite a bit. We went like 62 minutes, went a little long. But this is Galileo's drawings of the moon. Remember, this got him in trouble because he's starting to look at the telescope of the moon. And the church did not like this because it made, and there's the reason why I put this up there. This was the 8th question on the take-home, and it got pulled because they ran out of room. But this picture was on the take-home test, and it said, explain what's going on in this picture, in this painting. And in like 60 words, you had to tell me. So, the idea that Galileo is talking to this is a cardinal here, talking to the cardinal, and there's, I guess, his assistant, the cardinal's assistant. And he said, look, I'm telling you, I'm a religious guy too. We're all Catholics here, right? But I'm telling you that this is what I'm seeing through my telescope. And that really upset the church because everything in heaven should be perfect. So, why would you show somebody else? Why would you why would you ascribe all these pock marks to God's creation, heaven? We're imperfect down here on earth, but up there, everything's perfect. So Galileo is trying to, this guy says, so this Pope, this Cardinal says, I'm not going to look through that because the devil is in that tube and he's going to scale my eyes and make me think I'm seeing what you're showing me, but it really isn't there. So that's where dogma kind of wins out over facts, over, that's where faith, I suppose, wins out over science. And that wouldn't be happening today, would it? Like if this were a list of all the evidence of climate change, and these are our politicians, like maybe our politician from Oklahoma, looking at that and saying, nope, don't look at that, bury your head in the sand, and watching all this continued destruction because we refuse to look at the data. So it's happened to Galileo, and it's been happening for 400 years. It'll probably happen 200-300 years from now. It's just human nature to ignore things, science that you don't want to see. It messes up your dogma. And then finally, we talked about e per se muove, and we talked about that in the previous, but that's what Galileo said in his trial. He's going back to his seat, and still it moves. But I forgot to add this last week, and so I wanted to add this real quick. This is Galileo's finger. Now you can go, this is not some recreation, this is his finger. And you can go to Venice, you go to the Galileo Museum, they have this finger there in a jar. It's under a glass case. And it's just weird to look at it, think that is Galileo's finger. It's not a bone, it's just mummified. And it seems like it's really long, and it is, but this down here is that's the knuckle. So the knuckle right here. So you take this, you go from your knuckle up, you have a pretty long finger too. And all the meat, of course, is gone. Well, it's been mummified. So when you look at it, it says Galileo pointing to the heavens. Which think, oh, that's nice. But then you hear the real story, and that's actually his middle finger. So after he died, the story goes, after he died, Galileo's followers went and dug him up, which wasn't that strange back then. They used to have cadavers. I mean, they'd pay money. Even people like Da Vinci, would pay money. William Harvey, those kind of people that are doing, they're trying to study the body. They would pay money to bring in good cadavers, fresh cadavers. Well, they weren't doing that for Galileo. They weren't taking it to somebody to get some money. He was their hero, right? So they cut off his middle finger. And I don't know how long they hung out with the cadaver. That's a little odd. But they ended up thinking, well, okay, we can't just carry Galileo's dead body around with us all the time. It's starting to smell up the house. So I don't know, but they buried it again, but they cut off I don't know the whole story. So you guys need to go look this up and educate me. I mean, these are books that I've read 20 years ago, and everything gets meshed. But I know they cut off his finger, and it was the middle finger. And so students think, you mean the middle finger meant then in Galileo's time, 400 years ago, what it means now? Yes. In fact, in the Roman days, I mean, it meant the same thing, even way before that. So there's a story of, archers, like in battles, like the Saxons and the English and all, and they would attack like Braveheart, and then the guy would, the whole archers back there would be kind of behind the front lines, and they were sort of the prima donnas. So they would pull those, then all those people are running and going to attack, and then all these arrows come in. So they hated the archers. So when they would take over an army and win the battlefield, they'd line up all the archers, they'd cut off their middle finger because then they couldn't pull the bow back, And so maybe it's apocryphal, but there's a story of in a battle that the English won, or Richard the Lionheart, I don't know who it was. One of these, once again, clouded history. This should be called clouded history. It happened, but I don't know all the details. I'm not a historian, but I've read this stuff, and you can look it up, Wikipedia if you want. But so all the archers came out at the end and showed everybody, just showed their middle finger. I can't really do it, but showed their middle finger. Somebody get a screenshot on it. So they show the middle finger and they said, hey, we still got our fingers. So it was like this, it was a symbol of defiance. So if you want to write an English paper on the history of the middle finger, the history of the bird, it might be a good paper, really interesting. There's a lot of interesting history to it. But if you write that paper, make sure you include Galileo's finger in there. So they would go on the street. Oh, what they did was, sorry, I forgot the best part. So what they did was they cut that finger off, and they used to want to carry the finger around, so they put it on a stick. So they're carrying the stick around with this finger. I don't know why they didn't take the whole hand. That'd been better, right? And then just make the fingers go and right. Anyway, so they would chant on the street, kind of the Black Lives Matter of the time. They would say, "E Percy move," and then they would have that finger up there. Okay, so then we just kind of went through some of the back over some of the stuff we touched today in class. We quickly blew through this. And then the last thing we did was, with about 10 minutes to go, I let them work on their homework, which was this is 2.7, which was to do the Stegosaurus tail on this. This is a second order function, parabolic function. And so they, so they did this. They got off, they figured out what all the, we had some discussion back and forth. And they figured out what all these heights were compared to the 1 second, 1 second, 1 second, right? And got all our slopes. And then we plotted the slope. We wrote down those slopes here. So then we went and plotted the slopes, and that is the, okay, that is this. I'm showing you the whole thing. I apologize, but that is the V versus T graph. And those are the yellow steps. And then remember, we can collapse each step down to a point at the mid-time. Because at the mid-time, we said that at that point right here at this mid-time, it's like between 0 and 7 seconds. At this mid-time point right here, the tangent slope equals the secant slope. In fact, there's an essay question on this on the take-home test, the last question. So at that point, we can say tangent equals secant, which means we can say that instantaneous equals average. And so we can say at that one mid-time, we can say that algebra equals calculus. And so when average equals instantaneous, so right here, I can collapse each one of those steps down to the mid-time, and put a blue dot there. And then when I connect those blue dots, not connect the blue dots, but I get a best fit line through those blue dots, that gives me the slope of that here now. Okay, let me do this. The slope of this this slope equals acceleration. So we can actually, so it's acceleration in this case would be meters per second would be the units. But and we found, just looking at this, it looks like it's about 0.8 meters per second would be the acceleration of this object. And so it's hard to look at this. Like the question would be, well, looking at this graph, what's the acceleration? I don't know. I have to go through this process to find that the acceleration is in this graph. It's in this graph somewhere. It's hidden. So I have to kind of uncover it. It's like it's encrypted. So I uncover it and come down here and finally find out the acceleration of that curve. So if I said, what's the slope of that curve, you couldn't really tell me. But if I say, what's the acceleration of that curve, that is a constant. And in this case, it's 0.8 meters per second, okay? And that's all. There is, I did kind of assign homework. I said, look at the back, look at 1 through 6 on the back, and just look that over. It's the same curves on the front, and ask you questions about it. And we'll discuss that tomorrow, and then we'll go on to 2.8. Okay, so stop sharing. And that was quick, 25 minutes. That's a new record for me. But we just didn't do a whole lot today. Joke Monday, all that kind of stuff, so we just didn't really, tomorrow we'll get into more. We won't have so many announcements and passing back tests and all that stuff. All right. I'll see you guys Tuesday. Bye.